Okay. Hi, everybody. Good morning. We're going to continue talking about trigonometry today. Last week was really review. Everything that I had you guys do last week, Pythagorean theorem, special right triangles, even right triangle trig ratios, you had learned in geometry. Today, or this week, I want to expand on your knowledge of trig. And specifically, we're going to start looking at trig problems in non-right triangles. And one of the first applications that I like to look at is triangle area. Now, you guys all know that to find the area of a triangle, you can do 1/2 times the base times the height of a triangle. Well, what I want to do today is look at how we can find the area of a triangle when we don't necessarily have these values given to us, and how trigonometry can play a role, and eventually we'll see that there's an alternate formula that uses trig that we can use to find triangle area. So to see how this works, let's just look at an example here. So here I have a triangle where I'm given one side 29, I'm given another side 33, and the angle in between here is 55 degrees. And let's say I want to find the area of this triangle. Well, thinking about my area formula here that I already know, I would want to find the height of that triangle because I have the base here is 33. If I can figure out the height, then I can use this formula and I can find the area. So to find the height, I am going to use trig. So I have 55-degree angle, this is the opposite, and the hypotenuse. So I'm going to use sine. So the sine of 55 degrees is equal to opposite over hypotenuse. And a little algebra tells me now that the height is equal to 29 times the sine of 55. Now I'm going to keep this exact here because I don't want any decimal approximations yet. So now if I want to find the area of my triangle, I can use the formula that I already know, which is to say I can do 1/2 times the base, well the base is 33, times the height. Well, I just figured out the height is 29 times the sine of 55. And now I can plug all of that into my calculator to get an approximation of the area. So we'll do 1/2 times 33 times 29 times the sine of 55. And we get approximately 391.96, and that is in centimeters. Okay, so this process that I just did where I used trig to find the height and then used that height to now find the area, that can be generalized, right? So it seems like any triangle where I have an angle, a side, an angle, and then the two sides, or in other words, the two sides and the angle in between. If I have side, an angle, and a side, if I have this combination of sides and angles, it looks like I can always use this process to find the area. So let's try generalizing this a little bit. So here's basically the same picture. I have some angle we're just going to call angle C. I have this side that I'll call A, this side that I'll call B, and of course we'll call the height H. Notice again here I have a side, an angle, and a side. So let's kind of generalize using the process from above. So if I was wanting to find the height, I would say, well, the sine of this angle, the sine of angle C, is equal to opposite over hypotenuse. And solving for the height, I would multiply both sides by b. And so I would get b times the sine of c is equal to the height. Well, now that I have an expression for the height and I know the base, which is a, my area can be found using my classic triangle area formula, which is 1/2, excuse me there, times the base times the height. Well, my base is this A right here. My height, well, I just found that up here. It's B times the sine of C. And here we get a generalized process, a formula that we can use to find the area of any triangle when we're given side, angle, side like this. So this is often called the side, angle, side triangle area formula. 1/2 times A times B times the sine of C. 1/2 AB times sine C. And again, this works only if you have a triangle where you're given a side, another side, and an angle in between. And if you have that combination, you can just take those three values, plug that into this formula, and you'll get the area of your triangle. All right, so kind of a cool little application of trigonometry that works on triangles, notice, that are not right triangles. And this is just a handy little formula we can now put into our toolbox of trig things to use when solving problems. Okay, hope that made sense to you. You'll see some area problems like this on this week's assignment. Be sure to check out my next video, which is going to cover one more formula that uses trig ratios. All right, have a great week, everybody.